welcome back to the tutorial. And in this tutorial, I'm just going to be talking about the comparator. So now, as you saw, comparable is pretty good in defining the standard and natural order for sorting for your own class or any of the user-defined class for that matter. But let's say you define the comparator method in your student class to sort according to the say name here, and that's good because that is how it is required in most of the places in your particular use case. So for 90% of the places, someone is going to ask, "Oh, can you sort the list containing the student?" Then you know that they want the sort to happen according to the name itself. But suppose what if in one place or in one condition or in one scenario you are asked to sort the list of the student object according to their age and not their name. So it will be a very bad practice to go and change the implementation of the compare to method in the student class just for this one scenario against the many other scenario of names. So for these kind of situations, comparator anonymous class comes into the picture. It is this comparator anonymous class is actually responsible for overriding the sorting order of the data inside the list dynamically without having to go into the actual class and change the compare to method. So a sorting order from comparator actually overrides whatever order was written with the help of comparable interface in the compare to method. So let's take a look upon the class how it works. So this was our previous um, code. So what I'm gonna do in this, as you can see right now, we are comparing it according to the age. So okay, let it be this way only. So what happens if I want in this scenario, if I'm running this class and the output I'm getting is the comparison or the sorting according to the age, and someone asks me, hey, can you sort the data according to the name of the student? And I don't want to go here and change this to name because it will really be a bad practice, because in this particular scenario I'm only using it in one place. But it could have been used in a lot of places, and it's not really right to change the actual implementation because it will affect all other places where this compare to method has been used. So in this particular main method, if someone is asking me, hey, in this main method, can you please give me the sorted name and not the list, sorry, not the age? What I'll do, I'll use a different method from the collections utility class, which is called sort itself, but it's kind of a um, overloaded method, the second one, as you will see. So the first parameter it takes is the list itself, and the second parameter it takes is the comparator. What is it? We'll see. So this one is the list itself. Here what we'll do, we'll create a new comparator. This is an anonymous inner type interface. We'll implement it, and as you can see here, it's a generic interface again. So what it wants again the data or the object against which it will be compared to. So we want to compare the student, sorry, student object here. Now it will ask me to add the unimplemented method, and in this case the method which it implements is the compare and not the compare to. Make sure to distinguish between these two, and it also has two parameters instead of one, because in the last case what was happening, the this kind of used to be the second parameter, and the first parameter is the whole class itself, which is represented by this keyword. As in, this complete object is first parameter, the second parameter is this. But in this case we don't have the reference of this keyword here. So what it happens is that it has two parameters, the first one and the second one. Now what I'm gonna do, be doing is called compare to, sorry, no, sorry, we'll be doing get name here dot compare to, and then we'll do get name again, and this is what we're going to return here. There you go. So this time what we have done, in the actual student class, we were comparing with the help of the age against the age of the students. But now what we have done, we have overridden that comparison of the student class, and what we are doing, we are implementing this comparator anonymous data type, and we are saying, hey, collection.sort, can you please compare with this compare and not look to the actual implementation of the compare to. And I'm overriding it with this implementation or this algorithm. So if I run this now, you'll see the data has been sorted according to the name. And now is A before, then P, then T, then V, and then W. So this is what the purpose of comparator is. The comparator is basically used the functionality wise it's same. It is used to sort, but it does not affect the original class. Our original student class is exactly the same. We don't have to touch it. If someone else is using our comparator method in some other XYZ class, they remain untouched because it doesn't matter to them. In this particular class, we wanted the sorting to happen on the basis of the name and not the age. So we overwrite the actual implementation of the student class, and we did it. Same can be happen. Same we can do with the help of uh, the main or the basic Java types like string and all, because we don't have the access to the string. So even if you want to change the compare to method of the string, we cannot because it's not in our hands. So in those scenarios, we can just use the comparator method, and instead of the student, we can pass in the string, and we can sort that particular list of the string in the manner we want and not in the actual natural order of the string. So that was kind of the whole purpose of comparator here. But before we round up, I would like to talk about one more thing, and that is the tree data structure. So as you define the comparator here, same thing happens with the tree data structure. By tree data structure, I mean this either it can be either a tree set or a tree map or any other structure which is dependent on the tree, which has the base of tree. So we know that tree data structure automatically sorts the object inside it in natural order. If you're saving anything in a tree map or a tree set, it will automatically get sorted. So this natural order is nothing but the order defined here in the comparator method of the object we are storing in the data structure. So in case your class is not really implementing the comparable interface and overriding, implementing the compare to method, then you are going to get an exception. So let's take a quick look on that too. So what I've done here is that I've removed this comparable interface here and removed this compare to. I've just commented out so that our student class doesn't have, is not implementing these interfaces. So in this main method, what I'm going to do, I'm just going to remove all these things and add. Okay, we'll add a set here, student type, call it student set, and we'll add it set here. There we go, right like this. Now what I'm gonna do is that I'm gonna add these student objects here. Dot add let's quickly add 1, 2, 3, 5. Okay, so what we have is that we have student objects. We have a preset and we have added the data in the preset. Now if I try to print, let's see what it gives. If we run it, we will get an exception, and the exception says this one cannot be cast to java.lang.comparable. The reason being our preset, or as I said, preset internally maintains a natural order of the data in it. So it is trying to add the natural order of the student object, student 1, student 2, student 3, student 4, and all those things. But to add the natural order, it needs to compare these objects against each other, and there is no way in the student class to compare these objects. So because comparable methods not there, so we'll remove these comments and we'll override this and see what happens now. If we run this now, we'll get our data, and the data which is in this student set is is maintained in natural order. And what is the natural order? The natural order is based on the age itself, because that is what we have defined in our student class here. It is maintained as age. So we see it's 21, 29, 32, 43, 56. So that is what it's not just about tree set. Even if we use a tree map here, so the data in a tree data structure is stored in their natural order, and whatever data we are inserting in a tree data structure, we have to make sure that that particular data, the class which is actually that data should implement the comparable interface and the compare to object must be overridden or implemented there also. So that was all about the comparable and comparator interface, guys. Thanks for watching.